Okay, this is Note-Taking Guide 5.7 for Mathematical Decision Making for Life. So we've been talking about probability, you guys, but today we're going to talk about compound probabilities. A compound event is a combination of two or more events. So any kind of probabilities that would have more than one thing happening. We actually talked about two kinds of compound probabilities the last time we did a note-taking guide. Does anybody remember what we talked about last time? No, you guys. Dependent or independent, right? Do you remember how when we did those probabilities, there was always usually two numbers that we were looking for, right? Did one probability depend on the other one? Was it independent? Those are called compound probabilities. So today we're going to do those probabilities as well as some others. One of the other kinds that we're going to do today is called mutually exclusive. So there's some pictures here that kind of try and explain it to you. I try to give you all the symbols so when the probability is written, you'll have it. But what that is it's the probability of A or B. The key words here on these are or. So we're looking for whether or not it says or. If it does say or, when we find our probabilities, guess what we're going to do to them? Add. That was good. Nice job. Add those together, right? Do you remember the other day when we did the probabilities for dependent and independent? What did we do with them? We multiplied them. So a little bit different on these ones. So mutually exclusive is going to use the word or. When it uses the word or, we're going to make sure that we use addition for the probabilities, okay? It's going to use this symbol right here. This is called the union symbol. And mutually exclusive actually means that two things can't happen at once. So here's an example. Being a freshman and a sophomore. Can you be both of those at one time? They will never overlap each other, right? So those are called mutually exclusive. So that's one kind of probability we're going to find today, okay? Another kind of probability we're going to find today is called overlapping events. Now, when we look at it on a Venn diagram, the overlapping events are this part inside here, right? So we're looking for, again, the word or. And this time, when we have these overlapping events, so like this part right here, it says find the probability of A or B. Well, A or B can't be A and B. This part right here would be the A and B, right? So we actually have to find the probability of A. We're going to add it to the probability of B, and we're going to subtract out the probability of both of them happening at the same time. Okay? So that's kind of what it's talking about there. Again, it's the word or there. We'd find both probabilities, subtract off the overlapping probability. Okay? An example of that happening would be being a band and a girl. Being in band and a girl. You can be a girl in a marching band. That's totally okay. All right? The next kind, and we already talked about these before, are independent events. Did you notice again on the formula, we're back to multiply. We did that the other day when we did independent events. Independent events are two events that don't affect each other's outcome. When we do those, we're going to multiply those together. The key word there, if you didn't notice it the other day, is the word and. And when that and happens, we know we're going to be multiplying probabilities. An example of that is flipping a coin and rolling a die. They don't relate to each other. The probabilities don't affect each other, so we're going to just find the probabilities and multiply them together. We also have previously done dependent events. Dependent events that was when one thing affected the probability of another. So like picking marbles out of a bag and not putting the marble back, where we change those events. Again, the key word on that is going to be and again, when we find those probabilities, we're going to multiply them together. So what are we going to do when we see the word or?
We're going to add.
We're going to add, and what are we going to do when we see the word and? We're going to multiply. If you can remember those two things, you're going to be fine, okay? Here's our first example. You randomly choose a card from a standard deck of playing cards. Find the probability that you choose a queen or an ace. Or means, what are we doing with our probabilities?
No, add.
Yeah, or is add. We're going to add. So we're going to find the probability of a queen, and then we're going to find the probability of an ace. So what's the probability of getting a queen? Yeah. 4 out of
51.
52, because there's 52 cards in a deck. So 4 out of 52. Again, because of the word or, we're going to add. And then what's the probability of drawing an ace? 4 again out of 52. You guys don't guess on adding these, just let your calculator do it, unless you know you're really good at fractions. There's been a ton of mistakes made today on simple fraction arithmetic here. So what do you get when you do that?
2 13.
2/13. And you can just let your calculator do that for you. Okay, questions on how I did that? Okay. Now I want to point out to you for just a minute on this example that I know that these were mutually exclusive because I can't have a queen that's also an ace. But when I read this next example, it's not going to be that way. Find the probability that you choose a king or a club. Don't we have a king that is a club though? So do you see how that would be this part right here where we're going to add the two probabilities a bit together and then subtract out the probability of the overlap of it happening together, okay? So what's the probability you choose a king? That would be 4 out of 52 again. What's the probability of a club?
20. No.
Half are red, half are black, so that would be 26. And then half of them would be,
13.
yeah, there you go. So we know there's 13 clubs out of 52. Do you think it would have also been you would have been all right thinking 1/4 of the cards are spades, right? Because a fourth of them, there's only 4 different suits, right? Okay, what do I have to subtract off of there? How many kings are there that are a club?
You just add 13 and 14, right? 2. Oh, no. Yeah.
Okay, wait. Let's do the overlap. There's one card that's a king and a club, right? So I have to subtract off the 1 over 52. Okay? So you really have to do all 3 of those in order to get that probability.
And that's 4/13.
It is 4/13. Nice job on the calculator. Okay, questions on how I did that? Does that make sense that there was an overlap part that needed to be subtracted off? So that's what we're looking for when we're doing those, is if there's that overlap that needs to be subtracted, okay? All right, next set of examples on the other side. Number 3. Find the probability that you choose a card with an even number or a heart. Again, or means I'm going to be adding, correct? So even numbers. So thinking about even numbers, we're going to have 2, 4, 6, 8, and 10. Right, those are our even numbers. So 2, 4, 6, 8, and 10. That's 5 cards in every suit. So how many cards altogether in the deck?
26.
So 5 cards per suit, right? So 5 times 4 would be 20. So we actually have 20 out of 52 that would be even. Plus, how many of them are hearts? 13 out of 52. Then we have to subtract off the ones that are hearts and even. Do you remember how I said how many there would be in each suit?
5.
There's 5. So we're going to have to subtract off the overlap, which is 5 over 52. When we do that, that would be our total probability of that happening. So punch that in your calculators for me. 7/13.
Yeah, is that right?
That's what I got. Thank you. Questions on that?
Oh.
Okay. Number 4. Find the probability that you choose a heart or a spade. So are those going to overlap? Can you have a heart and a spade at the same time? Nope. And then the word or means add. So what's the chance of a heart? 13 out of 52. What's the chance of a spade? And that adds to be
1/2.
yeah, 1/2. So, and you probably could have thought about that one and just known, right? If you're taking the hearts and the spades, isn't that 2 full sets of the 4 sets of cards? So it should have been half, right? Okay, questions on that? All right, example 5. A coin is tossed and a 6-sided dice is rolled. What is the probability that the coin shows heads and the die shows 5? What am I doing?
You're multiplying.
I'm multiplying. Do you see how it's going to tell you whether or not you're multiplying or adding? If you're looking for those keywords, it's going to help. Okay, so a coin is tossed. What's the probability of getting heads on a coin?
1/2.
1/2. And then the dice shows a 5. What's the probability of rolling a 5 on a dice? 1/6. So the probability of doing both of those would be 1/12. Okay, questions on that problem? We good?
Yep.
Okay, example 6. What is the probability that the coin shows tails and the dice shows an odd number? So tails would be,
1/2.
and then an odd number,
What? 1, 3,
is
5. So 3?
yeah, so 3 out of 6 or 1/2 again, right? So multiply those together.
1/4.
1/4. Questions on that? We doing all right still? Okay. Example 7. This is more like what we did the other day with the dependent and independent. It's actually one of those two. So think about it as we do this and see what happens. So an aquarium contains 6 male goldfish and 4 female goldfish. You randomly remove one fish from the tank without replacement. Then you select another fish from the tank. Mrs. Clark. Sure. Okay, bye. All right. Then select another fish from the tank. What's the probability that both fish are male? So total fish, 10. We don't replace the fish, right? So 2 male in a row. What's the first one for male? 6 out of 10. The second one for male?
6 out of 9.
How many male fish are left? Yeah, so 5 out of 9, right? Multiply those together and what do you get?
10. That's 1/3.
Yeah, 1/3.
Did you say 10? Yeah.
That's close, though. 1/3. Thank you. Okay, 2 more quick problems here. Number 8, use the following information to determine if the events are independent. If they're independent, we multiply them together. If they're independent, when we multiply these together, we'll get 0.35. So you just have to multiply the 0.5 and multiply the 0.7 and see if it equals the 0.35. Because it does, the answer is yes, these are independent. Okay? And then the last bit here, it shows the table of values here. We're going to quick do this table, but actually